Hello everyone, welcome to another episode of your weekly dose of Terraform. This is this is gonna to be a pretty interesting episode. I wanted to say because I'm gonna to have Waldemar Hummer with me. He is CTO of LocalStack, and we will be looking into LocalStack maybe from a little bit more kind of pragmatic perspective. What I mean by pragmatic is that I want to see whether LocalStack can be a good fit for Terraform AWS modules, for serverless development with Terraform, and in general, if there are any questions by anyone, don't hesitate to write them in chat, and we'll make sure to answer them during this stream. So let's start with a little bit of announcement, because, well, who doesn't like announcements, right? Let's see. So, the first announcement which I want to say is that if you like what I'm doing, or if you want to support what I'm doing, you know the way to do this. You can go to GitHub, and my username is Anton Babenko. You can see here, and you can join these 42 amazing sponsors. And I'm not going to take more time than that. You already know how to do this, and you pretty much know what I do as well. Weekly TF is one of the projects which is growing very, very nicely. Lots of people are reading, more than 2,200 people already subscribed through emails, and I have some feedback on the content, so keep it going. It's really helping me to understand what is relevant and what is interesting for many of you. Next week is going to be HashiConf in Amsterdam. I will be there, and if you are there as well, let's say hi to each other, and it will be fun. So, LocalStack, right? That's why you are here. I guess you want to know what is LocalStack, and hope I'm fine. Yes, thanks, I'm fine. LocalStack. LocalStack is, as its official website says, a fully functional local cloud stack. Cool. And LocalStack promise that we can develop and test cloud and serverless application offline. I like word offline. Let's see how much offline does it actually mean. Well, you can go to localstack.cloud, read about all of this, see cool diagrams which were drawn in cloudcraft.co, which is probably already well aware for many users. So you can just explore this stuff here. I may sound a little bit slow, or maybe my thoughts are not very well aligned, because there is just a lot of content which I want to squeeze into this episode. So I'm not gonna to study website so much. So bye-bye LocalStack website. Ta-da! Okay, let's see something more exciting. Documentation, right? You go to documentation, you want to know, and you probably already thought like, okay, AWS is publishing lots of services continuously. What is actually the support of the services inside of LocalStack? So, let's maybe start a little bit earlier. What exactly is LocalStack? Well, LocalStack is a CLI or local server which you can install on your local machine quite easily, or inside of different CI system. And it will allow you to configure AWS CLI as well as Terraform provider to call local endpoint instead of public endpoint. You probably think about, okay, AWS is again having lots of different services. How well they are supported? Well, if you go to AWS feature coverage website, you may see that, oh my God, there are a lot of services, right? And a lot of features are supported. A lot of this with several stars, which indicate is that this feature support is pretty good. It has a lot of resources, a lot of features are implemented, so that's pretty good. I have to say that in many situations this is true, but I will go in details in a second, and I will show what exactly is implemented, how it is implemented, and more specifically we will be looking into how, if I'm using LocalStack, running AWS endpoint available for my local environment, how certain can I be that the code which I wrote, which interacts with LocalStack, will be working with public AWS endpoint, right? Because apparently production is not working on your local machine. Though you can do this as well. You can have Terraform code pointing to LocalStack, which is running on your local machine, and users can hit your local server quite nicely. You don't need to even have AWS for that. Isn't it cool? So you don't need to use AWS, you can just host everything in LocalStack. We'll be looking into a real project which I have created and I showed on different conferences, and I will show how LocalStack is useful or not useful. We'll also look into some cool features related to Lambdas and how Lambda can be used for how usage of LocalStack can help developers to work with Lambdas more efficiently. And see hot swap a little bit more quicker and more interactive. And we will be looking into EKS. Okay, EKS is pretty cool. I guess a lot of people are using it according to statistics of Terraform AWS EKS module. So that's going to be fun. So I'm coming back to support of individual AWS services, right? You see a lot of stars, you are thinking, okay, what exactly is supported? How can you be sure? And for that, I have to say there is pretty cool solution, right? You have Terraform AWS provider, and then you have LocalStack Terraform test provider. What this is doing is pretty much running CI script which will execute the same Terraform acceptance test as from Terraform providers, because, well, that's here it is. And it will be using LocalStack against this Terraform AWS provider. So literally every night they execute LocalStack against Terraform provider to make sure that whatever is published inside of Terraform AWS provider is not breaking existing functionality. It does not mean that everything what is supported in Terraform will be available through LocalStack 100%, but at least it guarantees that many tests are not failing, so that nothing what was working before is suddenly breaking. I think it's the right way to do, but I clearly understand that this can be a lot of work to maintain, because Terraform provider AWS is big and it's growing, and there are lots of features, lots of refactoring going on from time to time. So it's probably a pretty complicated project. Okay, we will talk to Valdemar in a bit, and we'll mention this as well. So let me look into some practical use case. Okay, and I want to show how specific it can be. Okay, well, I'm in my more convenient environment, which is IDE, where I can show some code, click around, and hopefully impress you guys with the power of LocalStack. So where to start? Let's look into the recent example which Waldemar presented 2 days ago, because it works well. What I mean by that? We have this type of configuration where we're creating an EKS cluster, some IAM role. So very simple example to create EKS cluster. What can we do for that? Well, first of all, we can we have to install Terraform or AWS CLI. It depends what you want to use. LocalStack also comes with certain utilities, which I install using pip. So pip install AWS, what was it? AWS CLI local and Terraform local. So this is the command which I run, and it install a couple small Python wrappers. The only function which this wrapper do is it generates or it overrides endpoints which AWS CLI is interacting to. Terraform local is generating provider file, which I will show later, and this provider file will be used as well. Okay, let's see. So I run this command already. There is no need for me to run it again. So if I see this piece of code, what I normally run, of course, I run Terraform apply, and it will use my AWS credential, and it will try to create these resources on AWS. Today, mostly I'm going to call tf local, which is provided by Terraform local, and as I said, it is a wrapper, so it does exactly the same as Terraform, with only one exception. So when I run Terraform apply, you see the same output. When I run tf local apply, the output is similar, but there is a small difference. Here is a file which was generated by this utility. It's called LocalStack provider override. And as you can probably know, that if file is ended with override.tf, this is extra feature of Terraform. Well, not extra, it is, I would say, advanced feature of Terraform, which normally you should never ever even know about and never ever use it. I have to admit that LocalStack is using this feature in the right way. There are a lot of companies who are trying to come up with usage of this feature, and it's just confusing. Here it actually belongs to the right place. So what this means is that if there is AWS provider defined inside of my own configuration, Terraform will use this file and it will override this provider with this piece of code. So that's good. So again, tf local generated this file, and then Terraform is executed and it's using this provider. As you can see, access key and secret key, it doesn't look real, but endpoints are all pointing to my local installation of LocalStack, which I have started in the process nearby. So let me show how I started this one. I will stop it for now, it's quite easy. And I started just by LocalStack start. I have also specified a couple environment variables which I will be relying on later, like debug equal 1, as you understand, to see a little bit more debug information, and lambda remote docker equal 0, which means I don't want to use remote docker. Again, it will be relevant when I show hot swap functionality. But the relevant one, which is kind of related to the piece of code which I'm showing here, is provider override EKS equal mock. What it means is that LocalStack will not try to do any API calls. It will really mock all responses from the provider. Again, you will always be in the situation where you think like, okay, so what I'm actually testing? If I mock everything, what exactly I'm testing? What is the reason for that? Well, the reason for that is that you want to have a real EKS cluster created, but it should run just on your local machine. And if you don't provide this provider configuration, but use, let's say, real AWS provider, then let me run this one. So then it will create real EKS cluster. If you have been creating AWS EKS cluster before, you probably know that it will never take 0 seconds to create, right? It's something like 30 minutes, 20 minutes, it depends on many things. So having 0 seconds and actually having a cluster is quite impressive, I would say. Well, you may think like, well, cluster was not actually created because I cannot do anything. Well, that would be just strange, right? So here we go. We have Cube app somewhere here. And as you can see, the content of this is quite straightforward, right? And it reminds you the way how you can manage Kubernetes resources. So if I want to run, if I have created this EKS cluster, there is this configuration to connect to it, and I can run tf local apply, no, tf local init first, and I'm going to run tf local apply for the first time. So if it doesn't work, don't blame me. No, it doesn't work, but okay. In theory it should work. Why it doesn't work, I don't really know so much, because I didn't write this code. But the point anyway is that you actually have a real Kubernetes cluster created, and yeah, that's pretty much it. You have configuration for it, and if you run Terraform apply, it will execute it. Okay, let's move on to something a little bit more maybe realistic, or maybe like pragmatic, I would say. What I mean by pragmatic? Well, as you probably know, I have quite a lot of Terraform AWS modules which I always want to improve. And as I started this live stream, I want to be, by introducing new tools into the pipeline, into kind of daily routine of any of my projects, I want to increase the certainty of my code, so that it works better and everything becomes really more efficient. So let's see by cd term, cd, which example do you want? Well, let's try with simple one. I don't know if it works. I usually like to try different things just because they may work or may not work. And then if it doesn't work, then I can look into it and think about why it doesn't work. So tf local init, again, tf local and Terraform, that's pretty similar thing. Upgrade because I changed to M1, but it's still thinking that I'm using my previous laptop. Cool, so what's going to happen here? It's going to create DynamoDB table. So this is example for DynamoDB table module, where it's creating just one resource. Well, sounds simple, right? If I click yes, I wait a little bit of time and it's created. Cool. So far so good, I would say. So if I would be able to put LocalStack inside of CI, and I can execute examples on each pull request, what kind of benefit would it get? Well, the main benefit is that the code is actually working. But then again, we have the same question over and over. Does it really work? I would say that it works for some examples, but where it doesn't work, we'll see it with more complicated examples. In this case, DynamoDB table has pretty good support inside of LocalStack. That's why it was created. And again, since it was created in LocalStack, I don't have to pay for it. It means I can just do whatever I want with this Terraform state. I can just restart LocalStack and I will lose this data. That's pretty much what I want to have inside of pipeline, right? I don't care about spinning up thousands of resources and tracking them. I don't want to track them anymore. Okay, if I run another command like destroy, does it work? Apparently it does, because DynamoDB has very good support. Let's look into another thing, which is where is it? Right. Let's see how this can be implemented with really offline support. Obviously, if I'm streaming this right now, I cannot disconnect myself from the internet, but I can just pretend that I disconnect myself from the internet. So what I mean by that is, if I look into example of DynamoDB one more time, I actually forgot which module I executed during my preparation for this one, so that's why I pick DynamoDB, but it seems to be working fine as well. So if I look into this example, if I look into this override, as I mentioned earlier, the structure of this file is the same as typical provider configuration, except that there are access key and secret key set to some stage. Well, what is specific to these endpoints? The main thing here is that it's pointing to local stack and specific port always, except for few resources like where is this? Like S3. So what it means is that local stack will try to talk to this endpoint, and as you can imagine, it will try to go to internet, or it will have to be configured differently. More specifically, it has to be configured with S3 use pass style true, and TF local itself has to be started with another argument which says that S3 endpoint should not look like this, but it should be local host instead. So something like this. There is documentation for Terraform local. Once you customize it like this, for S3, you can use local stack completely in air gap environment. It will not perform access to the internet. I verified it because I disconnected myself from internet, and I was able to talk to S3 quite successfully. The way I did it as well, using another utility which is called AWS local, right? AWS local is a utility which I installed at the beginning using pip. Okay, so this small hack inside of provider will allow you to use endpoint for S3 as well when you don't have access to the internet. Okay, what else can be done? Right, let's look into a little bit different example. So it works for simple DynamoDB module, which you can see is just calling the parent module, and parent module itself is just creating DynamoDB table. Pretty simple, pretty boring. Let's look into something where it really makes sense. And this is EKS example. And no, CD EKS example complete. If TF local would work, I mean, if local stack would work with this example, I would really push a local stack immediately everywhere. So let's see, does it work? This is a much more complicated example, right? You can see that it's doing how many resources? 106 resources to add. And there are a lot of different type of resources, like security groups, a bunch of IAM, launch template, auto scaling groups, as well as most like VPC resources, subnet, like a lot of different resources. Okay, so will it work? Let's see. So far so good, right? And it's quick, right? It's quick. Oh my god, it does something I cannot imagine. You see how quick is it? You should be excited by seeing that creation complete after 0 second. Ta-da! Okay, so what we have here is the reality. Reality means that not all resources are supported in local stack. And for me, this also means that when user submit, let's say, pull request where they add something, I cannot just execute example, and if I see that, oh, there is an error. So it's pretty hard for me to understand whose error was it. Was it error by local stack or user did something wrong? in many cases, we can understand that this resource is not supported by LocalStack. So we can understand like, oh, okay, this resource is not supported, so then just mark this test case as incomplete. And here you can see that AWS EC2 tags is not supported, as well as Fargate profile is not supported, and something with AWS AMI data source. So when we are talking about not supported resources, it's fine, right? We can understand it. But when it comes to resources like data source, which is specific to my account, there has to be some ways how to instruct LocalStack to actually talk to my real AWS account, maybe sync this information from time to time, or do something about it. Well, I see that I'm a little bit far into this, and I still have not introduced Valdemar to everyone. So let me bring Valdemar now and continue from there. Ta-da! Yes, we can see you. Cool.
Hello there. Hey, Anton. Thanks so
Hello.
much for having me here, and great introduction so far. I'm really excited to follow along the samples you've shared already. I think we've seen Terraform for different configurations. I think the one that failed before, the EKS example, maybe was because we used the mock provider. That's something I realized when we were running through it, and I'm really looking forward to have now the conversation on kind of
Yeah.
how local can be used and some of the limitations.
Yeah. Well, yeah, we already have some question from Leia about working with Lambda. Yeah, I can see that we are like half way through the stream and we still have not even talked about Lambda. So I'll try to hurry up. Can we think about what can be the solution for this specific error? Can you explain how people can work around this one?
Mhm. Yeah, that's a great point. So data resources basically are used to fetch the state from an existing account. And currently in LocalStack, we have a predefined set of AMIs, which are basically synced from AWS. But it's been sort of some time since we last synced it from AWS. So we need to basically upgrade and update the code in there. One of the things that we could do is we can configure Terraform in a way that it actually fetches the data from a real AWS environment, and then kind of executing the rest of the resources locally. So I think we'll talk a bit about these hybrid scenarios, but I think this would be one option if we can configure Terraform to do this.
Yeah, right. Yeah, that's definitely a great improvement. If this issue is gone and we can somehow get a list of features or services, maybe through API, like what is supported, what is not supported, then we can figure out that this error is actually not from the user, but this error is simply because LocalStack doesn't know about this resource yet. Then this whole example, which, as I said, 106 resources, is working quite nicely. So that's very kind of promising. But for now, we cannot use this example and reliably tell to user that yes, this code works well. It doesn't contain errors. It doesn't produce any kind of strange resources or strange misconfigurations. So that's fine. Okay, let's move on to lambdas, and for that one, I want to go to a real example, which is one of my talk recently. So here is it. Let me show the code first. Here is nickconf, where I spoke 3 weeks ago. So here is inside of nickconf, we have a bunch of resources and nothing really special. It's just calling some modules, creating some resources. That's not the most relevant part for today. What I want to show here, and we'll go through the question by Leia in a bit, is specifically how to deal with lambdas. Well, lambdas are a very powerful mechanism by many reasons and for many people, for many use cases. So having it running with a LocalStack is quite a cool way. So tflocal init, just to make sure that I have everything correctly. So if I run apply, what's going to happen now? Well, no, I need to drop my... That's a kind of reality that you need to delete your Terraform state file because after you restart LocalStack, it does not mean anything anymore. So I need to delete this one. And again, it's kind of safe to delete it because there is nothing really critical. So let's look into this example. So what's going to happen is that if I run tflocal apply, it will create 32 resources. It will create all these 32 resources inside of LocalStack environment. And there are a couple things what I would like to specify. So the one is that if I'm running LocalStack, then I need to emulate all dependencies. And like in this case, I have already packaged this thing, and it is available inside of bucket called fixtures and under this key. In reality, I mean, in real AWS, yes, this is true. But since I'm calling through LocalStack, I need to actually prepare this. I need to call AWS local to make this bucket, and I really need to put this file there so that my Terraform tflocal command is able to fetch this from the bucket and deploy it. So if I run this code now, again, it's pretty quick. This is what I like. And when it returns apply complete, I'm even more happy. Cool. So what we have right now is that we created a bunch of resources. Again, that's no rocket science. Let's look into one feature which is called hot swap. It is here. So what I can do here, I don't need this provider. So overall, I just add this piece of Lambda function just to not use module because it's much simpler to show this way. So when we have certain S3 bucket and S3 key, and we run this code now, then LocalStack will be able to oh yeah, no, let's go back to previous example. It's still a little bit no, it's okay. No, it's sorry, let's... So if I run tflocal apply now, what's going to happen is that primarily just this resource is going to be added. Okay, this resource is fine. It's pointing to S3 bucket, which has special name. This name can be configured as well. And the S3 key is pointing to location. So this location is actually, well, it is a real location where I have this handler available, so it's everything valid. What is cool in this setup is that if I run this command now, it will do a lot of changes. Well, not a lot of changes. Most important, it will add new Lambda function, right? So it will add this Lambda function as it was configured, but you can see that it's also doing some changes. And this is another quite peculiar situation between LocalStack and real AWS provider parity. LocalStack does not have all features of AWS. And when we're talking about AWS, we always have to think about which AWS are we talking about? Which AWS region is it? Is it like ancient, like Ireland, or is it a little bit newer, like Frankfurt, or is it even China, or maybe it's GovCloud? Do you have a kind of explanation of what kind of region or resource do we have inside of LocalStack?
Mm-hmm. Yeah, that's a great question. So basically, we do support the different regions that you mentioned, including like all the standard ones like EU West or US East 1 and so on. Also the US Gov regions. There is not that much like functional difference between the individual regions. So that's why, as you mentioned, if there are certain AWS or Terraform providers that rely on a certain field to get returned for a certain region or not, then this is something where you might end up with this discrepancy that you just showed there, right? Some field getting added or something. What we're doing now is more and more what we call parity testing. Also, as you showed with the test suite that we run against the Terraform AWS provider, to really make sure that we also catch these differences between what's happening in local side and the real cloud. But that's kind of really an ongoing thing that we definitely work on a lot.
Right. Well, one thing related to feature availability between region, which I personally hit, was that ephemeral storage is not available in China, for example. So this code should not work. That's why if you run this in China, you need to specify ephemeral storage somewhere here, like as an argument. You have to specify that ephemeral storage size equal null. That's how you should do it in China.
That's really interesting. Yeah. Also, S3, for example, has a bunch of limitations with. So US East 1 is kind of the main canonical region, and then other regions behave differently with these constraints. So, and that's why it's great to have Terraform, because a lot of that is encoded in the provider itself, and we can kind of leverage that for our own testing.
Yeah, that's actually a quite big part to explain to listeners, is that you guys are not implementing provider itself. You are not writing anything what duplicates provider, right? Provider does its own heavy lifting of talking to AWS and understanding the graph and building whatever is necessary.
Exactly. Yeah.
Okay, let's look into this functionality of this function. So what I did right now is that this Lambda function was deployed using this hidden bucket, and if I now call this guy somewhere, does it work? Yeah, it works. So the answer is from this API gateway which was deployed, but apparently my function, this function is not connected to an API gateway, which is the the reality. Maybe I can change it here. Yeah, I can change it here. So it should be lambda function I ran. So what if I use lambda function func I ran? Will it work now? So if I deploy it. So what I want to do is that I want to use this newest lambda function when I hit get. And hot swap means that I should be able to change the source code of this function. And if I call the same get, I should have another response. So let's see how it works. The source was inside of this location. So if I go to this location and if I change fixtures, app, and index. So here if I change, it says hello from app2 and I say just updated. And you see I just save file. I didn't run Terraform yet. If I look into logs, I can see that previous invocation returned hello from app1. Again, I didn't deploy anything. Terraform state has not been changed. If I call this now, and if I look into logs, it will tell that hello from app1 updated, which means that I can just continue writing my cool and buggy Python code, save it, and that's it. And now if I hit my API gateway, which is deployed locally, it will hit this new function, which obviously produces an error. That's the way how it works. So when I was preparing for this one, I was kind of excited and I thought like, wow, that's a way how it should be doing and that's pretty cool. But then the reality hit. It's not so simple when we write this Python code like this. We often include a lot of requirements, a lot of dependencies, a lot of mentioning of different pieces of different services inside of our code. So what can be done? So first of all, if we are using AWS CLI, unfortunately I don't have example here. If I'm using AWS CLI and I'm talking to AWS, let's say S3 service, LocalStack will be able to patch my S3 endpoint, and it will make sure that I'm talking to my local S3 bucket instead of talking to the public one, which means that many resources inside of my local environment will be actually local. So yeah, it happens transparently. But for now, that's it about hot swap. Also, installing requirements is usually part of your packaging step, where you package and install dependencies, compile something natively, and so on. Currently, LocalStack does not do this. But I would like to know if there are some ways, or maybe there are some workarounds, how to run certain commands when LocalStack performs hot swap.
Mhm. Yeah, that's a great point. So one of the things we're currently working on is so the Pro version of LocalStack supports layers, right? So you can define a Lambda layer with your dependencies and basically package everything up. And what we're now working on is basically making these layers also hot swappable, right? So you can actually mount a directory of your layer into the function, and that would then be combined with your handler. So you can basically make changes in either of the two, and you don't have to, again, redeploy it. That's something we're currently working on. Also, apart from Lambda side, I think it's interesting in the container space. So ECS, for example, right, which is another, or even like Lambda container functions, which is another way to run Lambdas. And here we're also working in terms of, how can you actually get the code as easily as possible deployed into your Lambda function, into the container itself.
Well, and I think now it's time to answer Leia's question. Sorry that we take it so late. So Leia is asking, when working with Lambda, I add segments of code which runs only in local environments to be able to run and debug it locally. I even made a dummy context object. Does LocalStack solve this issue somehow?
Mm-hmm. Yeah, so this is a great point. It seems to me, if I understand correctly, that Leia has been essentially creating a setup where it's possible to mock the Lambda invocations locally. So essentially, if you have your handler code like the one that Anton is showing here right now, you could technically just mock it out from your test code. You just call the handler with some mocked out event and context. The nice thing is if you use something like LocalStack, this is provided to you by the runtime, right? So you don't have to create these mocks over and over for the different scenarios and use cases. You basically just deploy essentially your production code into LocalStack, and it will just work out of the box. So yeah, definitely a great use case for that.
Right. And follow up to Leia's point of writing code which works locally in order to simplify debugging. I'd like to talk a little bit about some sort of drawbacks or maybe limitations. So if we look into the code of, let's say this example is good enough. So what we have here is that everything is created in one provider. Like everything is using LocalStack because I was running it through LocalStack. If we look into ways of integrating LocalStack with the real infrastructure, how can we do this? Well, the first way is that let's drop TF local for now, and let's just emulate kind of the behavior of TF local. What I mean is that I'm gonna to not use what? Oh yeah, right. There is already provider with this alias. So what I want to do is that I want to use Terraform apply. So what's going to happen is that if I run Terraform apply, it will use this provider with alias LocalStack in order to create just this resource, because I specified provider here. Does it work? That's a question. I mean, if it's working, then I can explain why it works. If it doesn't work, then I can explain why it doesn't work. Well, it seems to work fine. So what's going to happen is that now all other resources which were created previously using LocalStack are trying to recreate in real AWS account because I have credentials available. While this single Lambda function will be created in the local stack, So if we proceed with all of this, well, it will actually break because now API gateway is created inside of real AWS account, but it's trying to point to Lambda function which is deployed locally. And most likely it will just fail because, well, there is no such IRN. So let me roll back this. No, it actually succeeded. Well, I'm so flexible, I can explain why it succeeded.
Great example. I love these live demos where you don't know the outcome. It's great.
Yeah, well, the outcome is that it will probably verify it on the later stage. So right now it just pointed to the function, but then during the invocation itself, it will produce an error and say that, oh, sorry, but this function is not well known. Okay, let's see if you see this integration was pointing to my local stack function, but now it's pointing to the real one. That sounds good. Let's say yes.
Seems to be that AWS is not verifying the
Yeah.
contents of integration URIs, right? That's interesting.
No, it will verify it on the later stage when I'm gonna to call this function.
Okay.
Then it will tell like, oh, you don't have permission to access to this function. And this error message, as far as I remember, is rather convoluted. So it's something like error or internal error, which is not very helpful. No, it will say internal failure. Yeah, that's pretty cool. Okay, so now I made, if I go to this example one more time, so I have created just this function inside of my local stack environment, which means that the rest of infrastructure is running in real AWS account, while just this small Lambda function is inside of my local stack. How can I prove this? If I run AWS local Lambda list functions, I can see that I have, I have created previously functions here, so they're still there. That's kind of the point of local stack, is that they will be gone if I delete them, but this function is still here. What else I can do? Well, since this is Lambda function which is running locally, I can still invoke this function, and the output will be inside of ffjson. So if I invoke it, then I can see, this is it. So the function is locally, and I can invoke it also locally. That's that's how it is. Okay, what else can be done with this way? Right. Sometimes we may want to look into what actually is going on inside of local stack. So obviously there are a bunch of different things happening here, including some errors. Sometimes I have no clue what kind of error is it, like who actually produced this error. So you need to do a little bit of archaeologist job and look into that. But I have to say that if you add resources one by one, or if you use it for like half day, like I did, then you become familiar with this kind of errors, and you understand that, oh, this is just because I wrote something very wrong. And like in this case, user code syntax error. So that's why the whole thing was broken. And so on. So if I now run, let's find window where I can do something. Oh my god, this is famous error 59. So if I run this local stack with logs, then I can see these logs in real time. I don't have to watch this start process. I can put it into detached mode and forget about it. So it is quite handy to have this these logs available. If you have big screen, you can put it on separate screen and have it. So here I have the invocation of the previous one. So overall, working with lambdas, I think it is okay. The missing bit here is, at least from my point of view, is when I'm using existing code like this Terraform AWS module for Lambda, where I can specify a lot of things, it still requires a little bit of extra work to instruct module itself that it is being executed through LocalStack. So there has to be a little bit of magic, which is rather hard to explain right now, how to tell the module itself, because you cannot use function, you cannot look and you cannot override content of the module. You can only call it. That's pretty much the point of module. And if we look into the source code of this specific module, what we need to change, I mean, in order to make local stack work, is that we need to specify this S3 bucket and this S3 key. So I think it's only, yeah, this is the only thing which has to be changed. Okay, let's look into more kind of specific questions. If you have any questions, please write them. If not, we can ask questions which were submitted before. So a couple questions is, are you planning to tackle additional cloud providers beside AWS?
Yeah, so that's one of the questions we get quite frequently. So currently we're still focusing very much on AWS because the surface area is quite big. As you can imagine, we have the largest followership and traction there. We also start looking into Azure, which is probably the one that we're gonna focus on next. We started a very early stage beta program a couple of months ago, which was just starting to emulate a few services. But maybe something I can share is that we're, a bit of a sneak preview. We're gonna be launching a first version of LocalStack in the next couple of weeks. So can't maybe share too many details, but there's gonna be lots of cool stuff coming out. Also including, basically we want to open up LocalStack as a general platform where you can plug in emulators. And we're going to show that it's not only possible to emulate and run AWS locally, but also other service providers. If you think about, I don't know, something like a Stripe API or Twilio or some other things that you might want to integrate into your application. So there's lots of cool stuff coming up in the next couple of weeks and months there.
Cool. Yeah, I was actually surprised when I look into integrations and I saw a bunch of different things where it can be integrated. It's already pretty complete, I would say. I mean, there is no place for anything else, but you managed to find place for it. That's good.
Yeah, and I think the advantages for the integrations is that, since we're working really on the API emulation level, it's typically relatively easy to create these wrapper scripts or just integrations to point to localhost. So that makes it a lot easier for us.
Right. And Ahil just said that he was about to ask about Azure. So that's good. If anyone has any questions, please let us know. Okay. Let's see, what is this? Hello, Lay again. Kind of home cloud. Yeah, exactly, home cloud. This initiative actually started in 2016. And currently there are 13,000 people in Slack. So it is kind of active.
Yeah, and I really like this comment because maybe just a quick point on this. We also want to enable, LocalStack, obviously as a test and development platform, but also for quick experimentation, right? For example, if you have users who may not have full internet connectivity or maybe not even the resource and budget to work with the real cloud, it really also enables it's an educational platform as well. And we actually have an educational program where you can get free credits and a free license if you're enrolled in a program.
Yeah, right. Another question is Jenkins on the roadmap?
So Jenkins, so basically there's the CI systems, including Jenkins. The easiest way would be to create a Docker Compose configuration and just start up LocalStack within that environment. We do have a lot of users, customers who are using it in Jenkins. Sometimes it's a bit more like custom built, and we're also hopefully going to be working on a plugin that actually makes it easier for you to plug it into your Jenkins instance.
Right. Yeah, that's at least there is a logo of Jenkins, so that's already 50% of success.
There you go.
That's good. And what about improving of this service? Like, how do you guys look into growing local stack? Because you started 2016 as an open source project within Atlassian, right?
So that's a great point. So LocalStack has been kind of a like an open source project over the last couple of years. It has grown over time. But now the last essentially 9 to 12 months, we actually have started building a team around it, a company. So there's an actual entity behind it, and we now have pretty big plans because our growth looks pretty good, and people are asking for more features on AWS, but also other cloud providers. And we're also introducing a lot of more systematic ways to deal with things like the parity with AWS. So we're developing a lot of new innovation and technology to make sure that LocalStack really behaves the same way as the real clouds. So maybe this is topics for follow up at some point, but we have some really cool stuff that's currently happening there.
Yeah, well, from my personal point of view, is that if there is a way to show, I mean, for real, that by using local stack, you get pretty much the same certainty that this code does what it's supposed to be doing, so that feature parity is on the same level, then it's really beneficial. Otherwise, just putting another tool into stack and say like, hey guys, now write code with bunch of conditions where this code is running. Like, does it run on my platform? Does it run on Terraform? Does it run on real AWS? All of this permutation is really setting it off, I would say.
No, I totally agree. And that is one of the key points we also focus on to make sure it's like a seamless transition from your local into CI and then into production. So, for example, in previous version of LocalStack, you'd have to configure like in your Lambda functions, you'd also have to point your AWS SDKs to localhost and set the endpoint always. This is now something, for example, that we just automate on your behalf, right? So you just
Right,
deploy basically your production code and it just works locally as well. And there's lots of other things to be doing there.
right. Ahil just mentioned that it would be interesting to integrate it along with Act, which we use to run GitHub Actions pipeline locally. So yeah, Act is definitely a cool project by Kelsey.
Absolutely, yeah.
What was it?
Our team members is looking into more tight integration with GitHub Actions. So we'll definitely take a look at that as well.
Yeah, this is a project which is kind of
Mhm.
popular way of testing GitHub Actions and running them locally.
Awesome.
Um, what are the similar tools or competitors?
Yeah, so there is a
It's
few.
secret. It's secret. Next
Yes,
question.
no, there's a few tools in the open source, also other tools that we depend upon and integrate into LocalStack. I think maybe some of the closest competitors are the ones who are tackling sort of these like hybrid scenarios where basically you execute your Lambda functions in the real cloud, but get like a local proxy. That's actually something that we're also increasingly exploring to because there might not always be a clear boundary between local and remote. You may have these shades of gray in between, and we're working with kind of use cases from customers and users, like how we can do things like proxying locally. If you have, for example, a DynamoDB table or an S3 bucket, you just have a local representation and then sync the data from the real production environment into your local. But we're still fortunate enough that we don't have any like very direct competition, I would say.
Right.
But let's see.
Yeah, well, that's probably because you started 2016 when many companies and many people were not even aware about infrastructure as code or like local environments versus real environments. So that's okay. We talked a bit about hybrid solutions like combining local and remote execution. How do you see this evolving also in relation to Terraform?
Mhm. Yeah, that's a great point. I think this, as mentioned, like the boundary will kind of be blurring, especially if we look into things like team collaboration. So we're focusing a lot in our also pro and enterprise offering into like how can we enable teams to most efficiently and effectively collaborate together. And that involves, for example, also state management. We have one feature that we call Cloud Pods, which is basically a way to take a persistent snapshot of your instance and then easily share it with your team members. And we can actually populate these cloud pods from a real AWS account. Right? You can point it at a real account, and then get a representative copy in your local and then share it with your team members. So I think those patterns will be super interesting, and we'll be happy to learn from the community, how you're using it, what kind of problems you're facing, and so on.
Right. Yeah, that sounds like very good direction. Other day I was reading about development environments and the future of development environments, and there was a comment that many of us are still developing on local, but several companies willing us developers to look into different like hosted solutions in the cloud because it can be cheaper, quicker, and so on. But then one of the trade-off is that you will not have easy integration with your existing tools, and one of these tools is actually like state management. I mean, I have my own state management, you have your own state management. Currently we don't share it, and cloud tools like the one like Coder or Gitpod or Code Spaces, they natively think about this so that your team development is actually kind of by default. So you can onboard developers in minutes and have consistent environment.
Absolutely. Yeah, this is great. So we recently built an integration with Gitpod, for example, where you can spin up a workspace and it already comes with a pre-configured LocalStack instance. So basically you can get sort of productive from the first line of code you write, immediately have your testing available there. This is cool.
Look, you briefly mentioned upcoming major V1 release, which took how much? 6 years.
Yeah.
That's
So there's,
really cool.
if you're familiar with this ZeroVer website, the kind of the projects that never out of the 0x version,
Exactly.
we're actually now sort of graduating and growing up. So we are actually going to have a version 1.0. And the reason we've taken a lot of time, also we're going to have a rebranding of our website and logo. What you can currently see is a very old and outdated logo that we've created again a couple of years ago. So there's going to be lots of exciting things happening over the next couple of months.
Cool. Yeah, so make sure that you update logo as well.
Yes, we will.
Good. Is EKS supported? If not, is it in the roadmap? How to handle services that are not supported in LocalStack? Well, I think it is supported, and I showed it at the very beginning of this live stream, because it's kind of big problem. And you can also replace EKS with any other big service or which takes a lot of time, like Elasticsearch or Elasticache or any other services. So they have support inside of LocalStack, but feature parity is different. So you need to look into it more. But I think the question is actually the last one. How to handle services that are not supported in LocalStack? Can you give advice?
That's a great point. So we used to have a roadmap page, which is now not really active anymore, but we're now creating a discourse forum. It's not sort of publicly released yet, but it will be a discourse that users can use to create feature requests. We're also going to share our roadmap more publicly and more openly. And then that's a good way also to upvote certain feature requests, for example, to get more traction on them. So we want to have a bit of a split in terms of the GitHub issues is currently really for anything that's operational issues, and then the discourse will be for more I guess roadmap discussions and going forward-looking features.
Right. Yeah, and if you are interested about specific feature coverage, go to example like for EKS, and you'll find quite a lot of documentation. From my experience, this documentation is quite precise and it's pretty up to date comparing to code samples which you can find in the wild on GitHub. A lot of these examples are they were written a few years ago, and most likely they don't even work anymore. So you need to be a little bit careful what you find. I'm talking from experience because I spent some time trying to execute some examples which were written a couple of years ago. For some reason they don't work. But large amount of these services have pretty good documentation.
Yeah, that's good. And also one more point is our Slack channel. So you can just shoot us an email to info@localstack.cloud and we'll send out a Slack
Yeah.
invite. That's a great way to interact with the community and get in touch.
Yeah, and the community is rather active. I mean, 13,000 people inside of it. I don't know, 10 messages a day. People asking questions. I mean, not just asking, but also answering. That's important.
True that, yeah.
Yeah. Okay, cool. Well, I think I have covered all of my content which I wanted to hear, but still there are some questions. So let's go on. What are the most valuable features in paid version of LocalStack? Well, yeah, that's a really good question.
That's a really great question. Yeah, so I mean, in a nutshell, you can think about the open source version has roughly sort of like 30 services, and then Pro has another 30 services. Some of the things like Cognito, EKS, API Gateway v2 with WebSocket support, and a bunch of others. And also the things that I mentioned before with cloud pods, like the whole state management and like advanced persistence. And we're also focusing more and more on end-to-end insights in your CI/CD pipelines, right? So that's something we see a lot. People are not using it only locally, but also in CI. So we have a way to kind of visualize CI runs. You can drill into the state and have like a very detailed insights. So I think those would be the core. So team collaboration, additional services, team collaboration, and CI insights.
Right. And I'd like to highlight that there is also a free educational license, as you mentioned briefly, which can be a quite good addition for people who are running workshops. So if, let's say, I would be running a Terraform workshop somewhere in a village where they don't have internet, then they can use LocalStack to provision whatever is necessary, and we never ever go to real internet. I think it's cool. Right. Okay. Cool. Thanks everyone for asking so many questions. And let's see, maybe I missed some other questions. Just let me know. If not, then yeah, what would you like to say as a conclusion, Valdemar? Do you want to share some? I don't know.
There's some closing words. So first of all,
Yeah.
thanks so much for having me here and the ability to talk a bit about LocalStack. Great presentation on the samples on your part. Usually I'm the one doing the demos, so it's great to also kind of observe sometimes, and you did a fantastic job at that. So yeah, I think just stay tuned for the V1 release, which is coming up in the next hopefully 2 to 4 weeks. So the next month, and then from then on, we're always very happy to just collect your feedback. Get insights into what are the services you'll be using most frequently, but also what are the things that are currently missing that we should prioritize and focus on. And
Right.
again,
Yeah.
different ways to get in touch with us, and looking forward to following
Yeah.
up.
Well, I think the link to Slack is actually somewhere here. Yes, this is it. So on the documentation page, people can click on localstack-community.slack.com and they can open account and join. Great. Okay, thank you very much, Valdemar. Thank you everyone for participating, for asking questions. See you next time.
Thanks so
Bye.
much, Anthony.